Hello, my name is Rakshit Kothari and I will now present our work on weakly supervised physically unconstrained gaze estimation. Physically unconstrained gaze estimation is the process of estimating a person's line of sight while they are far away from a camera and are free to move in any manner. The ability to track unconstrained gaze movements has several applications because it enables non-obstructive placement of a camera. Some of the challenges include varying image resolution, eye occlusion due to head pose, and a wide range of uncontrolled lighting conditions. Previous efforts have attempted to collect such unconstrained data using expensive and calibrated hardware, time-consuming experiments, and a large pool of participants. In this work, we challenge ourselves to learn gaze from freely available in-the-wild internet videos. Our goal is to leverage these videos to reduce data requirements for unconstrained gaze estimation. We also aim to improve performance of constrained datasets for unconstrained gaze estimation. Certain human activities offer strong priors regarding a subject's gaze position. This work focuses on situations when two subjects are looking at each other. The looking at each other activity, or LAEO, comprises of frames with bounding boxes of two individuals known to be looking at each other. This can be labeled quite easily as compared to deriving gaze. As proof of concept, we acquire our data from the LAEO dataset. Can we leverage in-the-wild LAEO data to learn gaze? Naively enforcing that predicted gaze must be equal and opposite leads to suboptimal and degenerate solutions. To mitigate this limitation, we enforce that the predicted 3D gaze of a subject and its 2D projection must fixate on its LAEO partner. To enforce these constraints, we need to approximate the scene geometry. However, camera parameters and subject shape are not known. The scene geometry is computed on each static image by using dense pose. We then assume that each subject fixates on the 3D mid-eye point of their LAEO partner. However, approximating the scene geometry introduces noisy gaze labels. To learn gaze from noisy gaze labels, we propose a weakly supervised gaze learning method. The input to our method consists of sequences of LAEO phase pairs. The collected inputs are then passed through a ResNet 18 network followed by an LSTM module and a fully connected layer, which predicts the mean and the absolute standard deviation of gaze. The predicted network output is then passed into a combination of self-supervised losses and a fully supervised gaze loss. We find that a combination of all self-supervised loss functions offers the best weakly supervised performance on the Gaze 360 dataset. The 3D geometry loss function minimizes the distance between the fixation point predicted for a subject with their partner's 3D mid-eye point. The fixation point is computed as the intersection between predicted gaze vector and the LAEO partner's face plane. We also enforce the 2D projection of the predicted 3D gaze vector to lie on the line joining the 2D eye centers of LAEO subjects. We enforce the LAEO constraint by computing a pseudo-gaze label during training as the weighted average of a predicted gaze vector and the inverted gaze from the LAEO partner. We also exploit the left-right symmetry inherent to the gaze estimation task. We reverse the sign of the predicted gaze yaw angle and use that as ground truth to supervise network output for a horizontally flipped image. For experiments which involve accurate labels, we supervise our network by maximizing the log likelihood of a given target gaze label on the predicted distribution. Gaze capture consists of data captured both indoors and outdoors with a narrow gaze distribution. ETH gaze consists of a broad gaze distribution but captured with constrained lighting and indoor environments only. LAEO significantly improves CROSS-DATASET performance of these datasets. We find that LAEO data helps reduce gaze errors for all gaze angles on both gaze capture and ETH gaze. Jointly training LAEO reduces the number of subjects required from Gaze 360's train set. If the number of subjects is fixed, LAEO improves performance with diminishing results up until full supervision. We present the first work to use in-the-wild videos of people looking at each other for 3D gaze learning. We propose a novel framework to learn gaze despite the presence of noisy labels and scene ambiguity. Our approach augments limited datasets and results in significant cross and within dataset improvements. Thank you. Our code is available on GitHub.